This is 3.1 quadratic equations. We're going to start by reviewing the key features of a quadratic equation. You're probably going to want to hit pause so you can write down all of these things, because I'm just going to run through them pretty quickly. First of all, every quadratic has a vertex, and that vertex we use the variables hk. We find h by doing the opposite of b over 2a. When we're working with a quadratic, we'll go over the a and the b if you don't remember where those values come from. And then we substitute, after we find h, we substitute it back in to find k. We'll always locate the axis of symmetry, which we abbreviate AOS. And it's going to be x equals h. So whatever our h value is that we found for the vertex will go in the place there. Our y-intercept we need to find. So we'll substitute 0 in for the x and solve for y. And then the x-intercepts we can factor, or we can use the quadratic formula. So whichever method you feel the most comfortable doing. All right, so let's take a look at how to do that on a quadratic. So we are going to be finding the vertex, the axis of symmetry, both x and y intercepts, and then we're going to graph it. So our quadratic equation in general, we have y equals ax squared plus bx plus c. So when I'm talking about a and b, a is a coefficient of the x squared, b is a coefficient of the x term. All right, so we're going to start by finding the vertex. Remember, vertex from our list is hk. And we find out our h by taking the opposite of b over 2a. So in this case, our b value is 2. So we're going to take the opposite of 2 over 2 times our a value. Now we don't have a number there. That means our a value is 1. So 2 times 1, which of course is just 2. So negative 2 divided by 2 is negative 1. So our h value of our vertex is negative 1. Okay? Then we have to find the k value. To find the k value, we substitute negative 1 into both of these x's. So we get negative 1 squared, and notice how I put that in parentheses. Anytime you substitute in a negative number with an exponent, you always have to have parentheses around it. Now you can put parentheses around when there's not an exponent too, but you don't have to. All right, so negative 1 squared plus 2 times negative 1 minus 3 equals negative 4. Okay, so now we know that our vertex is negative 1, negative 4. Next, moving on to the axis of symmetry. Axis of symmetry is easy to find once you know the vertex. It's just always x equals, and then whatever the x coordinate of the vertex is. So x equals negative 1 in this case. All right, so we have the vertex, we have the axis of symmetry. Now we need to find the x and y intercepts. Finding the y-intercept is probably the easiest. Because all you do is put a 0 in for both of the x's, and doing that eliminates those two terms, so you're just left with negative 3. So your y-intercept is going to be 0, and then your c value. This is the c value. So y-intercept 0, negative 3. To find the x-intercept, we put 0 in for y, and then you can either factor or you can use the quadratic formula to solve. So this one's pretty easy to factor. Something that multiplies to get negative 3 and adds to 2. We get x plus 3, x minus 1. So then we set these equal to 0. X plus 3 equals 0. X minus 1 equals 0. And we get 2 x-intercepts here. If we subtract that 3 to the other side, we get a negative 3, 0, and we add that 1, we get a 1, 0. So after you get those 4 pieces of information, then you want to go and put them all on the graph. So I'm going to graph my vertex, -1, -4, 0, -3, -3, 0, 1, 0. And then your axis of symmetry is an imaginary line that goes right through the middle. Your parabola should be symmetric on either side of that line. And there you go. So I want you to write down number 2, pause it, and then see if you can find those 4 things on your own. The vertex, the axis of symmetry, the Y-intercept, and the X-intercepts. And then come back and see if you got all those right. All right, we will start with vertex. So we want opposite of B over 2 times A, which gives us a -3/4. Then you're gonna have to substitute that back in for both x's. You probably are gonna need to use a calculator to do that, to find the y value. We get -3/4 for our x value, and then -3, technically it's 0.125. You're not gonna be able to graph anything past 0.1. But for the exact answer, there you go. That means that's our vertex, and then our axis of symmetry is x equals that -3/4. Okay, then we can do our y-intercept. Remember, that's the easy one. It's just putting a 0 in for x and taking the c value. And then we need to factor to find our x-intercepts. So remember, when we factor, we take our leading coefficient times our constant, so 2 times -2, something that multiplies to get -4, adds to get 3, and we're going to split the middle. So hopefully you did that and got 2x plus 4x minus 1x minus 2, and then you grouped it. If you forgot how to do that, maybe now that kind of reminds you, so now you can hit pause and finish it out. So then you're going to factor out what's common between each one of those groups. So we have x plus 2 and 2x minus 1. Set those both equal to 0. And we get an x equals -2 and an x equals 1/2. So our 2 x-intercepts are -2, 0. And 1/2, 0. So this is all of the information we needed to find before we could graph it, and then you could go to the graph and put that information on there. Now when you're graphing decimals, you just have to do the best you can. Graphing -3/4, that's -0.75, so just not over half, but not quite all the way to -1, and then a little past the 3. The x and y intercepts are a little bit easier to graph, thankfully. -2, 1/2. Now remember that axis of symmetry is that dotted line down the middle. Got a skinnier graph here because of that leading coefficient of 2. Had a vertical stretch. All right, and then number 3 is our last one. So please, again, write it down, hit pause, try to find those 4 things, and then graph it. And then come back and check and see if you got all the information correct. All right, so for the vertex, we take the opposite of B over 2 times 1. We get -1, put that back in. So our vertex is going to be -1, 3 after we substitute the -1 in for both of those x's. That means our axis of symmetry is x equals -1. So we have those 2 things, then our y-intercept, 0, and then our c value. And then we need to find our x-intercepts. So like the others, we can try and see if we can factor it, something that multiplies to get 4, adds to get 2. And you might have discovered that there's nothing that multiplies to get 4 and adds to get 2. So it doesn't always factor. So sometimes we have to use the quadratic formula. So if you remember quadratic formula, that's the one we sing the song to. Opposite of b plus or minus square root of b squared minus 4ac all over 2a. All right, so opposite of b would be a negative 2 plus or minus 2 squared minus 4 times 1 times 4 all over 2 times 1. When you simplify that, you should get negative 2 plus or minus a negative 12 over 2. That negative 12 underneath the square root is bad news for us. We can't take the square root of a negative number. So that tells us that we have no x-intercepts. Okay, so this parabola doesn't have any at all. So x-intercepts, none. So when we go to graph it, we have our vertex, negative 1, 3. We have our y-intercept, 0, 4. And we have our axis of symmetry that goes down the middle. Now 2 points aren't enough to make a good graph, but that's when our axis of symmetry is helpful. If we know that 0, 4 is on it, then the point on the other side of that axis of symmetry has to be on the parabola as well. It's like a reflection line. So negative 2, 4 must also be a point. Okay, and that gives us a little bit better idea of what our curve would look like for that. So anytime you're trying to graph a parabola, find the vertex, the axis of symmetry, the y-intercept, and the x-intercept if they exist.